Hey, welcome back. So in our last video, we learned how to put an observation into Skynet. And in this video, we're going to learn how to check our results, see what came back, see if it was good enough, or sometimes maybe it's not good enough and you want to resubmit the observation. Now keep in mind, observations don't come back right away. Sometimes they do, but often you'll have to wait hours or maybe even days, depending upon weather or availability of the telescopes. But they do eventually come back, and then you want to check them out. So let me share my screen. Okay, here we are back on the main Skynet page. So let's go to my observatory and optical observing. And the primary thing you have on this page is your list of observations, everything you've put into the system so far. You have an observation ID number. You have the name that you gave the observation. You can click on either of these for more information. We'll do that shortly. And you also have the state of the observation. For example, this observation right here is still active, meaning it hasn't been carried out yet. But I have many that have been completed. I also have a few that I've canceled. They were carrying out multiple observations, but I decided to stop it and do something else instead. Now, there are a couple ways to view this. This is in list mode, but we can also go to thumbnail mode by pressing this button right here. And this will show you the last observation taken for, the last image taken for each observation. An observation could consist of multiple images, like this one here consists of 4. This one consisted of only 1, a couple of globular clusters. Let's go to my second page. I got pages and pages of these, but I got a few interesting examples on the second page. So let's scroll down and take a look at, let's start by looking at this right here. This is M2. And just by looking at the thumbnail, you can see something's not quite right. There's a lot of light coming through the middle of the image. There's some dark spots in there as well. And this is because you're looking at a raw image. On this front page, this is just the raw image straight off the telescope. It hasn't been reduced. It hasn't been corrected. These cameras are really sensitive, and so they pick up all sorts of things. Manufacturing defects in the detector in the camera. If there's dust on the camera lens, you get these out of focus little donuts in your image, and this can all shine through onto your raw image. Let's click on this here. So this takes us to the observation page, and there's a bunch of information here. We're currently in list mode. Let's go to thumbnail mode here as well. And you can see here we have the same unreduced or raw image. I can click on it to get a big version. And all sorts of interesting stuff going on. So there's a globular cluster, lots of stars, and that all looks good. But see this checkerboard pattern in the background? This is the manufacture pattern of the chip, of the detector in the camera. If you have a little bit of cloud cover or a lot of cloud cover, particularly if you're imaging in bluer wavelengths, you sometimes see this. Also, see the little donuts, the little dark circles all across the image? This is dust on the camera lens. And as I said, this all shows up in the raw image. Now, also on this page, you can come down here to master calibrations. So we take these other observations, about 1/3 of all the images we take are calibration images, things called biases and darks and flats. And I'm not going to go into great detail about what each of these is, but they're measuring the capabilities of the cameras, the defects of the cameras in different ways. For example, let me bring up the flat image. This little button brings up a JPEG of the flat, and that looks familiar. That is, you can see the illumination pattern on the chip. You can see the crosshatch pattern from manufacture. You can see the dust that was on the lens that night. And these flats are taken very close in time. And we can then use this image to correct your sky image. Let me show you how to do that. So if you come down here, you have some settings. It's currently set to not reduced. If you change that to reduced and save it, give it a second, and it will reload that thumbnail, and you see it's much better now. We no longer have that central illumination. I'll click on it here. You no longer we'll see the crosshatch pattern. And most of the donuts have been removed. There's one that's particularly bad. It's not fully removed. And there's maybe a hint of the crosshatch pattern, but it's much better. And that's actually the default when you come to these individual observation pages. The default should be reduced. So you'll see the unreduced images on the front page, reduced images once you go in here. If it comes up unreduced, you just go and change that setting. Okay, let's check out something else. Back out here. Go back to the observation list, page 2. Let's see, what else do we have here that's interesting? Oh, here's a picture of Venus. Let's look at that one. That looks perfectly fine. That looks really good. Now, you know, in a later video, I'm going to show you how to load these into Afterglow and manipulate the images and make them even better. But just for a quick look, that one looks pretty good. I'd be happy with that. What else do I have? Let's take a look at this one. This is Saturn, and there is something wrong with this image. So you can see Saturn, you can see the rings, but you also see the streak running down the image. And that is telling you that we have a sticky shutter. So these cameras have shutters on them. They're iris shutters, open and close like an iris. And you know, these things for every single exposure, open, close, open, close, open, close. So this is the most likely thing to wear out. It's the you know, one of the primary moving parts. And after a while, they get a little sticky and don't close completely. And you end up with the light kind of dragging across the image. And so this is one that you may want to resubmit. Let me show you how to do that. So you just come over here and press the resubmit button, and it takes you back to the exposure page. So it's assuming you want the same target, the same filters, the same telescopes. If you want to change any of those, you can go back and change them at this point. And you know, if you want to change your exposure, you can as well. Maybe you want something a little shorter, a little bit longer, or maybe you just want to put it in again. If it's a sticky shutter, just observe it again and hope the shutter's not sticky next time. We do keep track of these things, and if we see a consistent sticky shutter problem, we'll get the shutter replaced. They're pricey, they're like $700–800 a shutter, but you know, we take care of things. And you just save and continue and resubmit the observation if you want to. Now, I'll show you something else that's wrong, but first let me bring the lab over here, because the lab has a fairly complete summary of all the different ways exposures can be wrong. So let me just walk you through that a little bit. Let's see, we're under how to check your images. So here's some things that we've already seen. I said if it's cloudy or partially cloudy, you're going to see the donuts. Again, that's dust on the camera lens out of focus. You can see the thinning or the manufacture pattern of the detector. Here's partial cloudiness, and so you can just barely see some of these donuts, but that's probably not good enough. But there are other ways that your images can be messed up as well. Here we have an example of wind pushing on the telescope, streaking out the stars, or maybe the mount's not behaving as it should. Remember, these mounts are tracking the sky, and if it's a little bit jittery, you'll get streaked stars. Here's an example. This is one of the planets kind of overexposed or scaled in a particular way so you can see its moon, and it's been shifted. It's almost off the image. So the mount was misbehaving, didn't keep it at the center or near the center. Here's another example of mount misbehavior. As I said, these mounts track the rotation of the Earth. They counteract. They're rotating at exactly the same rate as the Earth to counteract that. We call that tracking. And if the tracking, for whatever reason, turns off, the stars just streak through. Because remember, the telescope is sitting on a rotating planet. If you take a long exposure, you'll just see the stars moving through your field of view. Sometimes that happens. And here's an example where it's out of focus. The telescope, for whatever reason, is out of focus, so the stars start to look like those donuts. And we talked about this one already. If you have a sticky shutter, you get these streaks. And sometimes you can even see the shutter. There's the iris pattern. Here's another example. Someone left the lights on in the telescope. Sometimes it happens. Here we have a satellite going through the image. Not necessarily a problem. In fact, it's sometimes fun to catch a satellite. And if you have two of them there, that means you probably caught an airplane. On each wing, you have a light, and it's flying through that tiny piece of the sky that you're exposing on. And this one's kind of fun. This is a literal bug in the system. There's a bug sitting on the camera, and so we took a picture of this bug. I've only seen that happen twice. This is one of them. There's one more that I can show you. It's not in the lab manual. I'll probably add it. But let me go back out here to optical observing. It's on my page 2. And it's a Jupiter exposure where I overexposed. I think, let me just look a little bit farther. Nope, that was probably it. So let's take a peek at this here. And this was a whole bunch of Jupiter images. Some I'm using the U-band filter, doing different length exposures, some B-band, some V-band. So I did U, B, and V, and I did 0.3 second and 0.1 second. Just trying different things. U doesn't let a lot of light through, and remember, Jupiter's really bright, so you don't want to let a lot of light through. A U-band filter is good, a short exposure is good, and that's a pretty good picture of Jupiter. Now, if I come on down here, the last one, V-band, that lets a lot of light through, doing a 0.1 second exposure. So this is an example of overexposing. I've let too much light through the system. And so you can see it's kind of bleeding in the upwards direction. And sometimes if you really overexpose, it can really get elongated. And so, you know, I overdid it here. I may want to go back and resubmit that particular exposure, but I'm not going to because I have other ones in this observation that were good. Now let me show you one last thing. Down here in settings, you learn that you can switch from reduced to unreduced to the raw. There's also a scaling, a brightness and contrast scaling, and we'll learn more about this when we open these images in Afterglow and can really manipulate them. But here we're looking at a planet, and maybe we want to know if we caught any moons. And so you can scale it to look at just the bright thing, like the planet, or you can scale to low and really emphasize the faint things in the image, and you have some settings in between as well. So I'm going to set that to low and save it. It'll take a second. It has to reload all the thumbnails. You can see in the shorter exposures, they're a little bit noisier, but as I do longer exposures, higher signal to noise, though of course if you go too long you saturate. Let's load one of these here. So when I set it to low, now the planet, you know, it's too bright to see any detail. All the data is there. You just change the brightness and contrast back to bright object, and you can see the spot and the cloud structure of Jupiter. But if you go here to the low scaling, that lets you see these little dots around Jupiter, and those are the Jovian moons. So lots of things that you can do to check your observation. Again, if you're not happy with something, just resubmit it, and most of your observation should come back just fine. All right, I'll see you in the next tutorial.